Have you noticed this, maybe on the news or when you're on vacation? It really seems like our oceans are filling up with jellyfish. Well, it's not just your imagination. We are absolutely seeing a huge global surge in jellyfish blooms. It's kind of like a silent takeover, and it's a major signal that our seas are way out of balance. Okay, let's dive into what's going on. So, this is the big question we're tackling in this explainer. What is happening here? Is this just some kind of natural cycle? Or is something fundamentally broken in the ocean's ecosystem? It's a super complex puzzle, and the answer, well, it reveals a whole lot about the health of our planet. Now, the first thing that probably pops into your head is, wait a minute, doesn't anything eat these things? And that's a great question. You see these gigantic swarms and you just assume they must be totally invincible. But that's actually a huge misconception. They definitely have predators. And the list of who eats them is pretty surprising. You've got these incredible giants like the leatherback sea turtle. For them, jellyfish are a favorite meal. Then there are large, important fish like tuna, salmon, and mackerel. Some marine mammals, too. And believe it or not, even other jellyfish will eat jellyfish. But, and this is the critical part, every single one of these predator groups is in trouble. They're in decline, mostly because of us. Things like overfishing and plastic pollution. Those turtles, for example, tragically mistake floating plastic bags for their favorite food. Okay, so this brings us right to the heart of the mystery. If they have natural enemies, why on earth are their populations just exploding? Well, it turns out that the decline of their predators is really only one piece of a much bigger and honestly more troubling puzzle. The truth is, we have, completely by accident, created a perfect storm for jellyfish. We've changed the ocean's temperature. We've changed its chemistry. And in doing so, we've given these simple, ancient creatures a massive, completely unnatural advantage over everyone else. It really boils down to these four main things. First, our seas are getting warmer. Jellyfish love that. It kicks their breeding and growth into overdrive. Second, like we just talked about, they're losing their predators and their competitors because of things like overfishing. Third, coastal pollution, which has a really fascinating side effect. And fourth, our own buildings and structures. So that side effect of pollution is pretty wild. When fertilizer runoff from farms hits the ocean, it creates these massive algae blooms. When the algae die, they decompose, and that process sucks all the oxygen out of the water. This creates huge dead zones. Now, for fish and other complex marine life, this is a disaster. They either flee or they suffocate. But jellyfish? They're uniquely built to handle low oxygen water. So they don't just survive in these dead zones, they thrive where no one else can. And if that wasn't enough, we've basically built them the perfect nurseries. See, for part of their life cycle, a jellyfish is just this tiny little polyp that has to attach to a hard, solid surface. And what if we lined our coastlines with docks, oil rigs, piers, breakwaters, just countless perfect protected surfaces for them to breed on a massive industrial scale? So, we're faced with clogged fishing nets, beaches that are too dangerous to swim at, even power plants that have to shut down because their cooling pipes are completely blocked by jellyfish. So what are we doing about it? Well, the response has been very direct, very industrial, and kind of like trying to empty the ocean with a bucket. The most common approach is just good old-fashioned brute force. Authorities will use drones and boats to spot the giant blooms. Then they come in with these huge, specialized nets to round them all up. And finally, they either haul the tons of jellyfish out of the water, or more often, they just run them through these giant shredders on the boats and spit them back out. But, and this is a huge but, there's a major catch. This quote here really highlights the potential for this to backfire, big time. When you shred a jellyfish, you're basically releasing all of its reproductive cells right into the water. So the very act of trying to destroy them might just be an incredibly efficient way of helping them reproduce. You're turning one big problem into millions and millions of tiny new ones. Okay, so if just removing them is that tricky, why not just use them for something? Well, that brings us to the single biggest hurdle, 97%. That is the average water content of a jellyfish. They're essentially just intricate floating bags of water, which makes them incredibly inefficient to do anything with. Yeah, that high water content is really at the heart of why so many clever-sounding ideas for using all this new biomass just, well, they don't really work in the real world. Let's take a look at a few of the most popular attempts. Okay, so here's an idea that got a lot of buzz a while back. Jellyfish have salt, in them, right? So why not just process them and use them as a kind of eco-friendly de-icer for roads in the winter? I mean, it sounds perfect. You're turning a major problem into a useful solution. But the reality, as it often is way more complicated. First off, the cost to remove all of that water is just astronomical. Second, it's just not very good at melting ice compared to a regular road salt. And to top it off, the organic gunk that's left over can actually cause serious corrosion to cars and roads. So, a great idea on paper, but a total bust in practice. So what about other uses? Can we eat them? Well, some species are considered a delicacy, but the specific types causing these massive blooms usually taste pretty bad and can soak up heavy metals from polluted water. Okay, what about animal feed? Again, that 97% water content means there's almost no nutritional value. The most promising area, really, is in new materials. Researchers are looking into things like extracting their collagen for cosmetics or even creating carbon fibers. But this stuff is super early stage. It's not a solution for the millions of tons of jellyfish out there right now. So if our direct attempts to fight them or use them are falling short, we have to look deeper. The jellyfish takeover, it isn't the real problem. It's a symptom. It's a symptom of a much larger, much more fundamental change that's happening in our oceans, a change that goes all the way down to the cellular level. And to really get what's happening, we need a super quick biology lesson. Inside the cells of almost all complex animals, that includes you, me, a fish, a whale, are these tiny little engines called mitochondria. They are literally the power plants. They take oxygen and food and turn it into the energy that the body needs to do, well, everything. But they have one critical weakness. They are incredibly sensitive to heat. So here it is, the crucial point. As ocean temperatures get warmer, the mitochondria inside the cells of fish, whales, seals, all of this complex marine life, they start to break down. Their little power plants begin to fail. They literally can't generate enough energy to hunt, to reproduce, or even to pump their own blood properly. And this is the great divide. Jellyfish, because they're so simple, have a really high tolerance for heat. They can handle it. But as you move up to more complex animals, like fish, and especially warm-blooded marine mammals that are already generating their own body heat, that tolerance just plummets. They are living on a metabolic knife's edge. And this is what leads to a really stark prediction for the future of our oceans. We could be heading towards a planet that's split into two totally different marine zones. The warm waters around the equator could become completely dominated by simple, heat-tolerant life, like jellyfish. And that would leave the colder waters in the deep sea and near the poles as the last sanctuary, the last refuge for the fish and whales and dolphins that we know today. And that is the real emergency here. You see, evolution takes thousands, even millions of years. Whales and dolphins live long lives. They reproduce slowly. But the climate isn't changing over millennia. It's changing over decades. Within our lifetimes, there is simply no way for them to adapt in time. Their basic biology is being pushed past its absolute breaking point. So we have to end with this question. The jellyfish, they're not an invading army. They're messengers. They're showing us a possible future for our oceans, one that is simpler, way less diverse, and totally out of balance. Are we prepared for that? And maybe more importantly, what are we going to do to stop it from happening?